In this recording, we're going to use the calculator as well as our sketch to determine percentiles using their normal distribution. So we're going to be doing some pretty heavy-duty stuff, some cool stuff, and I think you'll like it. I think you'll like how it all kind of fits together. So our example is going to be a swimming example here, where we have a backstroker, and I'd like you to go through, underline all the important information. This is critical, the fact that it says her times are normally distributed. If we don't see that key phrase or something that is equivalent to that, we can't use the 68, 95, 99.7 rule. But because we see that, we are assuming that we can use this model. Remember, we said the model is not perfect, it's probably wrong, but it might be useful here because the data is normally distributed. How would we know it was normally distributed? Well, we would have gotten all her times, and we would have made a graph, and we would have seen that it kind of resembles that bell curve. So then we can apply these percentages. What I'd like you to do, underline the important facts, make that sketch like we made in the last video, put in all the mean and count up and down, 3 standard deviations in both directions, and then put your percentiles up on top. We talked about putting 50th percentile in the middle, etc. And then play the recording when you're ready to answer the questions. Okay, so I'll catch up with you. Hopefully you did all this stuff, and I'm going to do it lightning fast. Okay, so you've got a nice sketch laid out here, and making a good sketch, it says up here, always include a rough sketch to support your work. This will allow us to see your thinking, and it will also give us the confidence that, yeah, our answer makes sense, which is awesome, right? Confidence is awesome. Okay, so let's answer some questions. It turns out we're going to be able to use this same sketch for each of the 3 parts to Amy's swimmer question. Not always will that be the case. Sometimes there's overlap and it gets messy. You got to make a new sketch. But here, we're interested in the probability that her next time is more than 45 seconds. So our technique is, okay, find 45 seconds. These are all times in red at the bottom here. And hopefully that was no problem for you, right? You put the mean right in the middle at 0. That's where our standard normal model has its mean. And then you went up by the standard deviation of 2.3. Hopefully that was a piece of cake for you. So I'm going to mark where 45 is. I'm just sort of estimating like right about there. And I want to shade because it could be less than 45 or it could be more than 45. And in this case, I'm just going to make a little mark here. All right, and do some shading. And I'm going to make an estimate. Well, if that's like only 2.5%, I'm going to estimate that this is like, maybe my shading isn't even quite good. Maybe I should have moved it over just a little bit. Maybe it's more like that. So I've got just this tiny little bit over here. I'm thinking that's like, I don't know, from 2 over is like 2.5%. So that's maybe like only 1%. I'm going to make an estimate. And that's really important for you guys to get some intuition here. So I'm going to say estimate 1%. Just give me a ballpark, right? Then when I go to the calculator, I should see an answer like around 1%. All right, so cool. So let's go to the calculator. If you don't have your own TI-84, no problem. You'll use one in class. But here's what you'll do. We're going to go to the distur menu, which is right here. You probably never used that before. So second, and then the bars button. You've got some options. The one we want is choice 2, normal CDF. So go down, hit enter, and hopefully you have your stat wizards on so you have this nice menu. If not, I can show you in class how to get your stat wizards on. Okay. So what's the lower bound to our interval here? Okay. Well, the lower bound, if you recall, the lower side was 45. Let me write in that 45. I should have done that before. Okay, so 45 is here, and then it doesn't stop. It keeps going, but of course, there's not much to this, right? It kind of flattens out. So we have to put in a big number. Our lower bound is 45, and our upper bound is the biggest number you can think of. I'm just going to put in, well, it should be really infinity, but I'm going to put in like 99999, bunch of 9s, okay? What does our mean? Well, we have to go back to our problem statement. It was 39.7 was Amy's mean time with a standard deviation of 2.3. At this point, we can just paste it, and it will fill the numbers in the relevant position. The advantage of using stat wizards is that you don't have to remember, well, what goes first, what goes second. It's just like fill in the menu, let it chug, you got it. So, well, that's what it came up with. The cumulative distribution function says it's 0.01. Well, we thought it would be about, or at least I did, about 1%, and that was right on, right? So awesome. So our normal CDF, and we'll write down on our paper, what was it that we did? What was our tool that we used? All right, and then it says what we want to round to. Our proportions, we're going to round to the 1,000th place. Okay, so 3 decimal places there. It's important that we just attend to whatever precision is required by the problem. And so that's about like 1.1%, which says, yeah, that was awesome, a good estimate. Okay, and that's kind of the idea here. We're going to do that a couple more times, and using the estimate and using the normal CDF feature, we're going to do one together, and I'll have you do the final one on your own. So the next one we're going to look at is less than 36. This is going to be easy because we already have the sketch. We don't have to start from scratch. So let's do this one in a different color. Go ahead and mark where 36 is. Probably about like right in here. And less than. It's important that we shade. So again, I'm not overlapping with any of my other shading, so no problem there. And now I just need to make an estimate. So pop over here, my estimate. Well, what do you think? You look at these numbers, this 2.5 and this 16%. You write down your estimate and then play the recording. Okay, so hopefully you estimated, hey, right in here, well, somewhere between 2.5 and 16, I'm thinking like maybe 9%. I don't know. It would be a reasonable answer. Anything like between, 16 and 2.5. Somewhere in the middle there would be reasonable. All right. Okay, so now that we have our estimate, let's go to the calculator and use that normal CDF feature again to get an answer a little more precise, the nearest 1,000th. So, again, second, and then the distur menu gets you to normal CDF. We want the second choice. Okay, so I'm going to put in a really small number for my lower bound, right? Because this one, its bound is like negative infinity. So a way to represent that would be, well, it could be what you have here. I'm just going to put negative 99999, bunch of nines. Upper bound is now 36. Our mean was 39.7, and our standard deviation was 2.3. Paste. Looking for an estimate near 9. Well, it turns out I was a little bit off, but still reasonable, right? 5%. Okay, so 0.0538. I'm going to call it 0.054. Okay, so again, showing my work. Already got my nice sketch. I reused that sketch. And then I am writing out exactly what I put into the calculator, what the calculator gave to me. And then I'm confirming with my estimate to say, yeah, is that reasonable? Yeah, it's within tolerances there, okay? Okay, so I'd like you to work out this final one completely on your own. I'm looking for the probability that Amy's time is between 37 and 44. Use your same sketch. Make an estimate. Then go to the calculator if you have one, and find the answer to the nearest 1,000th. Then just play the recording and check your answer. Okay, so hopefully you did that. I'm going to go through this super quick just because I want to keep the video short, and you should just be using this to check your answer at this point. Okay, for my estimate, I've got somewhere a little less than 16. I'm going to call it 15%. Something a little less than 97. I might call it like 95%. So just for round numbers, between 15 and 95. I might say it's like 80%. Okay, something like that, just to give an idea. My answer should be close to 80%. Okay, so one more time. I estimated 80%, came out to be 84%. I'm pretty pleased with how that all came together. We'll get lots more practice with this because this is one of those things you just need reps with. You're going to get that in class. Thanks for watching.